A second method we want to explain or show you, introduce you to is drawing a diagram. So in addition to just guessing and trying something, let's draw something out. We have a physical situation or a geometric situation or some visual patterns here that you have a need to understand better. What we would do is draw it out. Just start drawing things out. And so in this Wonder Play Grow, I challenge the class, or what you would do in class is try to solve this same problem with pictures. And so drawing it out, there is the whole amount, and then you give a fourth away, and then you have a third left over, and then you give a third away of that, which then leaves you only half, and you give half away of that. And then you can see visually that it's always the same amount. And I didn't even use numbers, we just use a visual. And that is another potential useful strategy. I would say go ahead and take a look at this video, which is an explanation of how to solve this visually, which you may not have thought about at first. As soon as you saw the fractions, you thought, and maybe I got to do some with the common denominators, I got to do something. But if we relax and say, what methods can we use? What are some plans of attack we can do? We can go for it there. So play that video and take a look at how to solve a problem visually. We're just drawing a picture. Example 1.42 is another, it's actually a classic problem. We changed the problem to a fist bump, but if you want to Google classic, the handshake problem, this is where this comes from. But we can draw out the five people in a room. Each person exchanges a fist bump. How many fist bumps will we take together? And you will see, just draw out, there's the five people, and draw lines to represent a fist bump. And that when you finish connecting them all, you can just go ahead and count the lines. And it turns out there are 10 fist bumps. So again, a problem that can seem overwhelming at first, right, could easily then be solved potentially with just drawing something out. This is a classic problem for strategy later, which would be break it into simpler problems. But like, let's say we had only one person. How many fist bumps? Zero. What if you have two people? Then you would say, oh, there's one fist bump. Two people, one fist bump. Add a third person to this mix, right? Now three people. So you start with, and you let it grow instead of just starting with five. There's three. Then you add a fourth person to the mix. And then how many fist bumps will there be between them? So again, there's a lot of ways to model and capture our solutions. And there's your fourth one. And then you add the fifth person who shows up, and then you add those fist bumps back in. They got to do it. They got to do it. They do it here, and then you get that same answer. So keep that in mind. That's an example of drawing a picture or a diagram as we do that. So again, you will see again some more explanations here. And then the last strategy for this section is just using a variable. So if some of you feel really confident with your algebra, right, you can go ahead and then we can start to solve problems with variables. So here is a situation, classic algebra problem, just to get us going. And you could see the algebra to solve it. But I would also encourage like guessing and testing, right? We know what the cost is. We know how many tickets were sold. And then, how many total tickets. And you can just say, maybe it's 300 and 300. And then try it 300 times 2, right? You could do a guess and test method here also. I'm trying to see if you could do a drawing. And so as you get better and more confident, right, your mathematical mindsets start to change around what it means to do mathematics. It's okay to make mistakes. I can be creative. I try other strategies to see, oh yeah, that would work, right? Variable, you see the problem, you think algebra right away, but for sure guessing and testing would work. And then you could have an organized list and try to keep track of it. And then see the patterns that emerge to help you solve the problem. So just keep that in mind, right? As I have a note here, problems are solved using different strategies. And just because one works for you, another may work well for someone else, right? And so as a future teacher, that's an important recognition as you start to teach. Now, we're not in class, but if we were in class, we would spend a few minutes having groups work on different problems, and then think about the strategies. You don't have to solve it, but what strategies would you use to solve these problems? And again, there's no potentially right answer. You may use multiple strategies, but it's through a conversation of which strategy would you choose and why would you choose it. Lulu, Lulu the clown drops the ball. I think I would start drawing, but some people may start looking for numerical patterns and making a list of the numbers versus drawing. We have a cookie problem where you're doing fractions, and so I want to start with the numbers. Let me put a list of numbers. Or some of you want to draw it out like we saw the other one. So just keep that in mind as you uh, encounter different scenarios, problems. What would you do? Devising a plan. Now you've been introduced to different ideas.